Hello, Math 142. An infinite geometric series is convergent if absolute value of the common ratio R is smaller than 1. If it is convergent, it'll converge to the first term divided by 1 minus the common ratio. An infinite geometric series is divergent if absolute value of R, our common ratio, is greater than or equal to 1. Okay, let's do a few examples. Suppose we have 1 negative 1/2 plus 1/4 minus 1/8 plus dot dot dot, and this is our infinite geometric series. And we want to know if it is convergent or divergent. Well, look at, all I have to do is find one term and divide it by the previous one. In this case, if I divide negative 1/2 divided by 1, that gives me negative 1/2. So that's my common ratio, R equals negative 1/2. And absolute value of negative 1/2, that is positive 1/2, that is smaller than 1. So this geometric series is convergent. So this is convergent. Well, what does it converge to? So I'm going to say that it converges to a over 1 minus r. So that equals 1, over 1 minus, my common ratio in this case is negative 1/2. That equals 1 over, negative times negative is positive. So I have 1 plus 1/2, that gives me 3/2. And that equals to 2 over 3. So this, let me change the color very quick. This equals to 2/3. Let's do another example. Go to the next page. How about something like, suppose I have 2.4, negative 2.88, positive 3.456, minus 4.1472, plus dot, 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 dot. Okay. So if I pick any term and divide it by the previous one, I know I get that common ratio is negative 1.2. Okay, absolute value of negative 1.2 is greater than 1. So this geometric series diverges. Let's do a couple more examples. How about something like 1 minus 2/5 plus 4 over 25 minus 8 over 125 plus the dot, dot, dot. Okay. Well, to find the common ratio, I divide any term by the previous one. So I get R equals negative 2/5. An absolute value of negative 2/5 certainly is less than 1. So this is convergent. So convergent, what does it converge to? So I can say S equals A over 1 minus R, A being my first term, 1 divided by 1 minus negative 2/5. That equals 1 over 1 plus 2/5. So I get that equals to 1 over 2/5, and 5 over 5 gives me 7 over 5, and 1 over that is 5 over 7. It converges to 5 over 7. Let's see, let's do one last one. How about the geometric series 1 over 10 plus 1 over 100 plus 1 over 1,000 plus 1 over 10,000 plus dot, 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 dot. Okay. So I pick any of them and divide by the previous one. Let's say if I divide 1 over 100 by over 110, I get R equals 1 over 10. Okay. And my first term, look at absolute value of 1 over 10, of course, equals 1 over 10, which is smaller than 1. So this is convergent. This geometric series converges. But what does it converge to? Let's find out. So S equal A over 1 minus R. So that equals the first term, which is 1 over 10 divided by 1 minus the common ratio, which is 1 over 10. Okay, so I'm going to make my life easier and say that, okay, the numerator I have 0.1 and the denominator I have 1 minus 0.1. So that gives me 0.1 over 0.9. Multiply top and bottom by 10, I get 1 over 9. So it converges to 1 over 9. And absolutely last example, because these are like easy ones. So how about if I have negative 1 plus 9 over 8 minus 81 over 64 plus 729 over 512 minus dot, 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 dot. Okay. Dividing any term by the previous one, I'll find out that R equals negative 9 over 8. Okay. An absolute value of negative 9 over 8, that is 9 over 8, that is greater than 1. So this series diverges. Divergent. Okay, thank you. Talk to you soon.